Alright, so today we're gonna learn about depth first search algorithm. So right now we are on to our fourth type. So this is our fourth type, which is going to be the graph algorithms. So in the first graph algorithm that we're gonna learn is depth first search. So what exactly is depth first search? So depth first search is a traversal algorithm that explores a graph or a tree as deep as possible along each branch before backtracking. So first of all, if it decides to go on to X side, or let's say there are four roads, X road, Y road, Z road, and A road. So if you are using depth first search algorithm, it is going to take one road, let's say X road, and then it is going to explore it to the end of X, and then it will come back and then explore the Y until it reaches the goal state. So the goal state is our answer that we're trying to get onto, because depth first search is basically used to get like some sort of output. Mostly it is using AI technologies, like when you are creating any kind of maze game, then you use depth first search algorithm to find the roads, to find the routes, to how to get to the goal state from your current state, right? So it takes a road and goes to the end of it till it ends, and then it comes back and take another road. That's how the depth first search algorithm basically works. So this is the simple definition of depth first search. You can just pause it and write it down if you want to, and that may be helpful in your theoreticals. Then DFS can be implemented either a recursive approach or an iterative approach with a stack. Here's the general process. Start at the root or any arbitrary node. Then step 2 is mark the node as visited. Then step 3 is visit an adjacent unvisited node, mark it as visited, and repeat the process until all nodes are visited. If a dead end is reached, backtrack the most recent node that has unvisited neighbor. Continue this process until all nodes in the graph have been visited. So basically you have to like start from the current position and visit all of the nodes. Once you explore the node, you check the node. If it's not the goal state, you come back, you check another node, you come back, you check another node. But in this example, we're gonna just explore the nodes. We're not gonna see like what is the goal state and where we'll reach it and how many steps we take. We are just focusing on visiting the nodes, not finding any goal states. So let me just give you a brief overview of how this actually works. So depth first search algorithm is a pseudocode. Let's look at the pseudocode for depth first search. For simplicity, we'll just use a recursive approach. So depth first search, node, mark node as visited. Then what we do is run a for loop for visiting each neighbor in neighbor's node. And then if the neighbor is not visited, then we visit the neighbor. That's how it works. So this recursive function starts at the given node, mark it as visited, and recursively visit all the unvisited neighbors. That's how the depth first search algorithm works. So let me just give you a hands-on practical so that you can understand it more well, I guess. So right now we are on our coding screen. All right. So the first thing that we're going to do is just get started. All right, we're going to define the function basically because it does not require any kinds of like big class or something. It just requires simple function. So 3 arguments: graph, node, visited. If node is not visited, we are just going to check if node is not visited, then print the node and then visit the node, right? Because when we print the node, it's like visited only, right? So we're going to just consider the print as visited, and then we're going to add this node into visited. So visited dot add is equal to, no, not equals to, add node. And then we're going to check which node is not visited, which are the neighbors of it, right? So neighbors are the around given branches of that particular tree or graph, whatever that happens to be. In graph node, so we're gonna call it as recursion. So once it check that okay, X is visited, now what? The neighbor is Y, so it will recursively run this again. It will check whether Y is visited or not. If it's not visited, visited, and then check who is the neighbor of Y, Z. Check it is visited, no visited, then run it again, again, and that's how the recursion works. So now we're gonna create a graph as an adjacency list or whatever that happens to be. I'm not very good at pronouncing an adjacency list. I'm good at creating anyways. So a a is a particular let's just, if you were to visualize this, a is like a ball which has two childs b and c. B has two childs d and e. C has one child f. D does not have any child because it's leaf node. E have one child f, and f does not have any child. It is a leaf node. So you can just visualize it in your mind that how this would actually appear, right? And then just call the function once you're done with creating it. Okay, so use visitor dot set. Visitor equals to set. Oh, what the? All right, no. Print DFS, depth for search. It's not necessary to print these things, but I'm just printing it just for fun. All right. Visited. So it will give a simple output. First it will visit A, then B, then down the C, and then it will go up and check D. No, not A, B, and D, I think. Yes, A, B, D. Then it will visit, I guess, E, then F, and then C. That's how it works. And exactly as I said. So you have to just grab a piece of paper and design it as I told you to design, and then check how the depth first search algorithm works. And you can just take the output and understand this, that how does this actually works in the visual format. So thanks for watching this video. If you liked it, then click on the like button. If you didn't like it, don't click on the like button and just click on dislike button, and subscribe for more content like this. See you in the next one. Till then, keep watching Code with Akia.